Okay, so let's talk about some things with our graph, our analysis, how we're going to take these measurements and get actual results, actually to see, does our value of G match the 9.8 that we expect? So this is some sample data. Don't worry about this interval column here. We're not using that. I took that out, so just ignore that. So you found your displacement by measuring the points in between each of the dots. Do not use this data. This is sample data. If you do use this data, I will know because it's my data. Please use the data that you collected in the lab. So to get your velocity column, what you are going to do is you have two options. You can either take your displacement and divide by 1/60th, or its decimal form, or you can just multiply by 60, and that'll get you your velocity column, and you'll do that for all of your displacements. To get your position column, you are going to add up your displacements. So for the second line, I'm just adding up those two points, the 0 and the 0.8. Then I'm going to add up the third, or I'm going to add the third to it, giving me the 1.8. Then I'll add the 1.35 to get me the 3.15, so that by the very end I have basically the entire length of dots that you had. So in your sheets, if you're using the Google Sheet that is given to you in the Google Classroom, or if you're using Excel, you're going to put these three columns: your velocity column, your position column, and your time column. You do not need to put your displacements. You can, but you don't actually need to graph those, or you don't need to use them to make your graph. To get your position versus time graph, the time is going to be on the x-axis, position is going to be on the y-axis, so you're going to want to highlight those two and then create a graph. Please make sure they end up on the correct axis. Sometimes, depending on how you highlight it, they may switch, and that's going to throw your results off. For your velocity versus time graph, you're going to use time on the x again, and this time your velocity column as your y-axis. Same thing. Make sure they end up on the correct axes, otherwise it's going to cause problems. For the velocity versus time graph, so this is mine with my data. These instructions that are written here are also in your in your write-up, so you don't need to directly get it from here. So you're going to add a trend line, but to find the slope, sometimes Sheets does this weird thing where instead of actually taking the slope of the trend line, it takes like the average of the points. So we're going to use a function. It's called the Linus function. So actually, I'm going to show you how this is done. Okay, so here is some data from someone. Notice they have their time, their position, and their velocity. So you see that they have a trend line here, and the slope gives me something there. So in order to use the Linus function, you're going to click on a random box that doesn't have anything in it. You're going to type equals Linus, open parentheses, and then it says known data y. So we're going to highlight the data that was our y-axis, which is the velocity. So we're going to go ahead and just highlight the numbers. Then we'll add a comma. Then it says known data x. Well, those are our times, so I'll highlight those numbers. I'm going to close the parentheses and hit enter. And this right here is my slope. So this is actually 659 centimeters per second squared, also known as 6 6.59 meters per second squared. That's how you're going to get your acceleration. So in this case, the trend line did actually match up, but sometimes, I don't know, something really weird happens with the trend line and you get two different values. So using that Linus function is your better bet, generally speaking. So the step-by-step instructions are listed here. Like I said, it's going to end up looking something like this, but it's not going to be exactly that. It's going to depend on your particular Google Sheets. But it's just a way for us to get our most accurate trend line slope, which is ultimately going to give us our acceleration due to gravity. So you saw like this person, they ended up with 6.59 meters per second squared, which, I mean, is it awful? No. Is that we're going to use in our problem solving? Absolutely not. But it does show an acceleration, so that's okay. This is from some other data I had. This one came out to 946 centimeters per second squared, also known as 9.46 meters per second squared. So that's actually pretty good data for this kind of experiment. Some final reminders. So here's an example of someone's work. Please make sure your graphs have titles, labels, and the units. The few examples that are in this video, my graph, these graphs, the other graph I showed you, I'm not saying any of them are full credit worthy. Some of them definitely have mistakes in them. Some of them are generally very good, but you should be sure to include all your details in your graphs. For the D versus T graph, make sure that you put the time into sheets as equal sign 1 divided by 60, equal sign 2 divided by 60, and so on. You'll see, like, in all of these, it's an actual number. If you just put like 1/60, 2/60, Sheets doesn't know how to read that. And it's gonna tell you that it can't make a graph with that. So instead, you have to put equals 1 divided by 60. That gives you a real number. Equals 2 divided by 60. That gives you a real number. It does not know how to read fractions, so be wary of that. No units in your columns. Again, it doesn't know, it can't read that. So if you put it in every line, again, it's not going to make your graphs for you. For D versus T or position versus T, you do not need a trend line. For V versus T, you could put in the same sheet like this one is here and like the other one is. Number 5 and 6 in the write-up, you're going to answer after you've made this graph. You can't answer those questions until you've made that graph. Once the graphs are done, then you can answer the questions on the very last page about percent error, your procedure, and what sources of error you may have encountered. And then, please make an appointment on this Wednesday if you need some help with this stuff. Period 1, we're working on this in class on Tuesday. Period 3, we're working on this in class on Thursday. Honors, we're working on this in class Tuesday. And period 9, we're working on this in class on Thursday. So you still have plenty of time in class to work on this. Whole thing is due the 3rd at midnight. Please contact me with any other questions.